Hi there, welcome to part 2. We're going back. Okay, I was saying that we did a transformation where we went 6 units this way and 7 units this way. And when we did, we end up getting a T prime that is on the origin. We get an S prime out here, and we get an N prime up here. Okay. Now, what you could figure out is you could figure out where S is, or I'm sorry, where S prime is based on S, right? S was at -3, -7. I moved 6 units to the right. So my new x coordinate for S should be at 3. And then obviously this is right here on the x-axis, and that should be 0. You can also figure that out by saying I went up 7 units from -7. -7 plus 7 is 0. So I have that, and on the origin, hopefully you knew what that meant or you looked it up. That point is 0, 0. So if I have T at 0, 0, and if I have S at 3, 0, what's the distance between them? Well, the distance between them is 3, and this is going to be incredibly important. I can mark that one up, or I'll mark this one up down here, actually. It's probably a little better. I could have figured out this T as well. What is it? It should be at -6, -7. Okay. What is the length of Tn? So what is this length right here? So this is where you either have to remember trig or your special triangles. A 30, 60, 90 triangle, if I drew it all the same, if this were x, this would be x root 3, and this would be 2x. So if my 3 is x, my 2x would be 6. So the length of Tn, that segment, is 6. Hopefully you got that. Okay, Mr. Robinson rotated square ABCD 90 degrees counterclockwise about the origin. So hopefully you remember how these rotations work. You have those circles and all that. We talked about that a little bit. Okay, what did he do wrong? So to keep in mind, I did the rotations correctly. In other words, these points should be where they are. The problem is, remember, when these rotate, these actually go like this. A should should match up with that C right there, and this C should match up with that D prime, and this D should match up with the B prime, and the B should match up with the A prime. So the problem was the lettering, right? You want to correspond A with A prime, and A and A prime are in the wrong spot. So you would say something about the labeling of the letters. That's what was incorrect. On the plus side, though, maybe I could say, oh, you know what? I wasn't trying to do a rotation. I was trying to do a... What was the other transformation type? Well, the other transformation type that does this, that keeps the letters in the same spot, is a translation, just like in the last problem. It translates a little bit to the right and a little bit downward. And so name the type, so it's a translation, and describe the transformation that takes place. So somehow either write in a sentence how far they shift over and how far they shift down, or do it in translation form, like maybe the alligator mouths like this. So I'd say, pick a point here. I'll pick B. B is at -4, 3. B prime is at 3, 1. So going from -4 to 3, that was 7 units. So I went positive 7 units x direction to the right. And going down from 3 to 1, I went down 2 units. So that's a -2. So your answer should say something like either like this, or x shifted 7 units to the right and y shifted 2 units down, something like that. Okay, this one had a lot of questions and a lot of things you had to do. It'd probably take the most of your time. So first thing we asked you to do is take this and reflect it across this line. So remember, take every individual point, for instance, U, figure out how far away it is from the line, 1 unit, and draw its, I forget what it's called. Draw its image on the other side. Same with Q. How far is it from here? 1, 2, 3. Okay, on this side, 1, 2, 3. It'll be over there. Let me erase this marking I made. And the same thing for D. 1, 2, 1, 2. And A. 1, 2, 3, 1, 2, 3. And with practice, you'll end up getting this pretty well. Here's Q prime. Well, you know what? I'm going to disregard labeling those right now because I want to label them later. The next step you had to do is then reflect these points across the x-axis. So I'll refrain from drawing the lines here and just count them off. So here's where my reflected U image is. I'm going to reflect it now over here, and you have to count how far away it is, or to see it was 8 units away. Because it's 8 units away from here, this other point will be 3, -8 over here. Okay, so that one is officially U prime. Q, same thing. Q is 4 units away from X and from Y. So this will be over here, -4. So here's Q prime. And A, 10 units away, going down, -10 units away. This was A prime and D prime. 5 units away, and right here, 5 units down. There we go. So this is my, let's make this a little more official. This is my reflected image that I'm looking for. This is my isometry. And the thing is that this is a translation as well. And what is it equivalent to? Well, take every vertex and count how far away they are. So I'll go ahead and do U and U prime. This goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 units down, and it goes 0 units across, right? So your final answer should have been 0, -14. 0 units left to right in the x direction, 14 units down in the y direction. Okay, the next thing you had to do is reflect this quadrilateral across line L. So I still have these points. I'm going to use these again. Then across the y-axis. So this time I'm going to reflect them across here and draw the image. So let's go and do that. Here was my reflected U. 1, 2, 3 over. 1, 2, 3. There's that. And I'm going to go and save the time as far as teaching how to do this, because hopefully you've had enough practice with it, or you did it masterfully on this quiz. And D was 11 units over. Oh, no, yeah, that's right. And A was, see, I need practice too. A is right there. Okay, so that should be looking like this. A little bit. And hopefully you also labeled. So this is U double prime. This is A double prime. This is D double prime. And this is Q double prime. Okay, so the question here now is, what is the equivalent rotation from this to that? Well, you might be able to tell that this is your fixed point you're rotating across now. Just to generically put it, I'm taking this U, rotating it across to U prime. This Q, rotating it across to Q prime, etc. So it has nothing to do with the origin. Okay, these are rotating along this point. And what is that point? Well, hopefully you know that is 0, 7. Let me say about 0, 7. Okay, and how many degrees is it? Well, you have to draw the lines. U to U right there is a straight line, so that's 180 degrees across, and etc. If you do it for one point, it equates to all of them as well. So we want 180 degrees counterclockwise or clockwise, doesn't matter, right? So you could circle neither. Should have circled neither there. Whoops. And it's about the point 0, 7. Okay, how is line L expressed as an equation? Hopefully you're starting to get these a little bit more now. For every x value, x equals 1, x equals 2, 3, 4, 5, 6, 7, etc. For any value for x, y is always equal to 7. Okay, so that's how these lines work. This is the equation, y equals 7. Okay, true or false? This was a bonus question. Reflections are commutative. And what that means is, like, there's a commutative property in math. You can say A plus B is equal to B plus A. It doesn't matter what order we do the math in, they both equal the same thing. So my question is, what if I reflected this quadrilateral across the x-axis first and then across line L? Where would it go?